we'll just get started. And as usual throughout any of our sessions, please drop any questions or comments in the YouTube chat. And oh, sorry, I can hear myself back. And yeah, use the hashtag Scottish Developers on Twitter, and we'll ask those questions or give those comments in the stream. And I've already asked a few folks like where we're being joined from. So I'm in Glasgow. So I'm going to say sunny Glasgow, but that's definitely a lie today. And we've got Craig joining us from Edinburgh. We've got Ewan from Glasgow. We've got Ben just outside Glasgow. We've got Adam, another Glaswegian, and we've got Ali joining us from East Kilbride. So good to see so many people join us. Hopefully at some point soon we'll be able to actually have it that we can all catch up in person at a real life meetup. Oh, we've got Runa joining us from Norway. I think they win so far with our furthest away contributor. Oh, and another Ewan from Glasgow. That's funny. And today the main thing that we're going to chat about is getting started with GraphQL and .NET, and that's as good a time as any to add in Michael to the chat. So thanks for joining us, Michael.
Hi, everyone.
Hi, and where are you joining us from?
I'm joining you from Zurich. It's in Switzerland.
Awesome.
And I'm not Swiss, but I'm working here and living here with my family.
Awesome. Well, thanks for joining us. Yes, this is the great thing about, although we wish we could have real life meetups, we can have awesome folks join us from all around the world virtually. So that's the good thing about being in this virtual world that we're in at the moment. Would you like to let us know a little bit about yourself, Michael?
Yes, so I'm a Microsoft MVP and working here at the Swiss Life. It's an insurance company that focuses on pension funds. And a couple of years back, so 4 years back, I started Chili Cream, which is the organization that builds GraphQL solutions for the Microsoft platform.
Awesome. So a perfect person to be telling us about GraphQL and .NET then.
Yes.
Awesome. Well, I'll let you share your screen and we can get started.
Yes, let's go.
I think you still have to share your screen again.
Sorry.
No worries.
I thought it was still shared, but you're right.
There you go. We can see your screen now, and I'll say goodbye for now. I'll jump in if we've got any questions, so folks can leave it in the chat.
Yes, super. So, and if you have any question at any point, just write them into the chat, and I'll try, if they fit in the talk at the point where we are, I'll try to fit them in. I will occasionally have a look if there are questions, and then we can have a look at them. So as I said, I'm Michael Stipe, and I originally started with the topic of GraphQL more than 4 years ago, so in 2017, 2016. Around, and back then GraphQL was not really a thing. It was just starting to take off, and back then I started to implement the Hot Chocolate library and create the next GraphQL developer experience that is more on par with solutions in other ecosystems. But I know a lot might not have a clue what GraphQL is, so we will start at the beginning and slowly go and have a look at what GraphQL can give us as a .NET developers, how we can use it, and what problems we can solve with it. As we are an open source project, please help us by starring us if you like us. If you think, if you don't like us, you don't have to star us, so there's no force. But this is good for all open source projects. If you use an open source project, I really encourage you to give a bit of love back to the open source projects that you are using by starring them. Okay, with that, let's get started with the actual topic. So when we go to conferences and start talking a discussion about GraphQL, what is GraphQL, people are often a bit clueless still. So GraphQL, if you ask in the JavaScript ecosystem, or also other ecosystems like in Rust or in Java, most developers already have good experience with GraphQL and know what it is. And especially the JavaScript ecosystem is very keen on GraphQL. If you talk to .NET developers, they sometimes, if they have a bit of an idea about GraphQL, say, oh, why don't we use OData? Or it's essentially Facebook's OData, or things like that. But that's actually not true. Let's take a step back and talk about where GraphQL actually comes from and why JavaScript developers are so keen on using GraphQL. So GraphQL originally was developed by Facebook back in 2012. And they started using that internally to improve their data fetching needs that they had with their native mobile applications. Back then, in 2012, Facebook released its first slew of mobile applications, and they were not that well received. They had quite a lot of issues with them, like long loading times, a lot of large data consumptions and stuff like that. So the applications really felt sluggish on mobile networks, and they were really not nice to use. And Facebook back at that point looked at what the problem is. And the problem actually was that they did thousands of data calls to fetch over a very standardized REST API. So they built their mobile applications as they built their desktop applications. They essentially used all those web technologies that they knew and could use well with their Facebook portal, and just took them and put them in a mobile application. And that didn't really work out well. So Facebook really rethought how they can change that and make these mobile applications nice and usable for the user. And what they really went to is starting working on native mobile applications, so no more HTML and stuff. And they also reinvented how we can fetch data. And they came up with something called GraphQL. It didn't really look like this query here. This is a simple GraphQL query. You could say the hello world of GraphQL. With this query, the consumer, in that instance, the consumer of our API asked for the currently signed in user, and from the currently signed in user for the name. And if we look at this query, it kind of looks like JSON. And if we send that to our GraphQL server, we actually get a response that closely aligns that request. It almost looks like the GraphQL server took our request and just filled it up with some data. So now our kind of JSON-like query looks like proper JSON. But GraphQL is not just about simple data structures like an object and its immediate fields. It's actually more about trees of data. So GraphQL is really great with relations. So I not only can get those flat fields like the name of the user, I also can drill into other parts of my graph. For instance, get the profile picture and then get details about that profile picture. And again, if I send that to my GraphQL server would take that request and give me a response to that closely aligns my request structure. And when we look at that and see that it's actually about trees and relations, it's really great with related objects. I might not just want an image, the profile picture here for my user. I really might want to drill into relations of other objects, like maybe the friends on my service. So if you think about Facebook, you have the user, you have the friends. You just could drill in here and not only fetch the user details when your application goes up, but also get the friends list because you need that maybe on the left-hand side to show with which users you can chat or have conversations. So, and when we send that to our server again, we expect at this point that we get a response that closely aligns our request. Okay, that's good. But if we look at this request, actually, we can see that we have name and last seen like 2 times here. So me actually returns me a user object, and friends returns a list of users. So GraphQL actually has a solution for that, and that's called a fragment. And a fragment is in GraphQL essentially the primitive of composition. And it allows me to create a fragment hierarchies as I can create component hierarchies in my UI components or class hierarchies in my backends. And we will have a closer look at them when we go through the talk and look at their usability. It's mostly for client developers that they can better compose their queries. But we will have a look at that. Let's start with a little demo, because I just talked about the problems that Facebook had and how they tried to solve them. But it's good to do a little exercise to really feel what the problem is. And there is the standard GraphQL example, which is the Star Wars example. And the GraphQL community really built that example to show off the actual features of GraphQL, why GraphQL has a leg up on REST. And that's because there is a REST API called the swappy.co. It actually does not anymore be called swappy.co. It's now swappy.dev, because the initial maintainer of swappy.co stopped working on that. So they branched it off, and now we have this swappy.dev. And it's essentially a REST API around the Star Wars universe. So REST API around Star Wars data that shows really a well-formed REST API and how to interact with data. And GraphQL essentially wrote a little GraphQL layer on top of this data, on top of this service, to show what the benefits of GraphQL is and what it tries to solve. So a little experiment that we can do, or a little task that we can do here, is maybe fetch a list of characters that appeared together in movies with Luke Skywalker. So what we want to do is aggregate some data with this REST API that builds a list of characters that appeared together in movies with Luke Skywalker. And this is actually something quite easy that we can do with this REST API, because this REST API offers us all the data about Star Wars. So what we would do is maybe look at the structure of the service. And that is easy enough. So I have here my API root. So I could just have a look at that root, and there are other tools like this. This is a very old API. So we now have Open API that describes that differently, but essentially the idea is the same. I can have a look at the structure of my API here. I can see that my REST API consists of a couple of endpoints here that we call resources. So REST is built around this concept of resources, where I can interact maybe with people that are my character objects, or with planets or films or spaces or what have you. And I can interact with these resources through a certain kind of verbs. In this instance, we have get, head options that are the verbs I can do with these resources. In a real life REST endpoint, we might have more things like to mutate data, like put, post, and what have you. But for our little task, this is enough. So I want to fetch all the characters that appear together in movies with Luke Skywalker. So I might start with the people endpoint and just have a look at that. And if I look at the data here, the REST request, so I'm doing a get on people, I essentially get a list of my character objects or person objects. And I can already see that there is Luke Skywalker with a ton of data about this character. I also can see that this character has relations, like I can see it has relations to films, to species, to vehicles, to starships, and what have you. And these relations are exposed here as URIs, on which I can do a request again. So I essentially could click on the link here, and then I get the next request, fetching that film. I also can see that my character here has also an endpoint. So if I just add a 1 to my people here, and then I'm just fetching the first character, which is Luke Skywalker, so just this character. And then I still can explore other data. So if I would write a little algorithm to get that data, I might want to fetch Luke Skywalker first, then iterate over this films array here, and then fetch each of the films. Let me just have a look. Okay, let's just drill in from here. So I would then just drill into the film object here, look at the data. Again, it has relations to other objects, in this case, characters. And these are the characters that played in that movie. So my algorithm first fetch Luke Skywalker, iterate over the films array, fetch the film, and then fetch each of these people. Just take the name of this. So fetching maybe object 2, people instance 2, just take the name of this, and we would have our list of characters. But if we just calculate that together, so this actually would be a first request. Then we have, in this case, 4 more requests. Then we have to do per movie, requesting all these characters. And we would quickly go up to 140 requests. I know that because I wrote this algorithm actually, to fetch that data. That's quite a lot to fetch just a list of movies. And just let me have a look. I think I actually have this algorithm also here, just to get a feeling what that means. And that would be Cambridge. Okay. So this is actually a piece of HTML with JavaScript where I wrote this little algorithm to, as I said, fetch this data. So essentially we are going here, fetching Luke Skywalker, then iterating over the films, then fetching each of these characters and so on, and at the end printing that list. So just for fun, let's run that. Open with, let me just, can I drag that? Reveal in Finder. Let's drag that onto our site. Let's just run that. And you can see that it took 4.6 seconds, 4,600 milliseconds to grab all the data. And let's just have a look at the developer tools. Was actually not good to. Yeah, now it's cached. Even cached, it takes 700 milliseconds. But you still get an idea of how many requests it does. You can see it's a ton of requests. And now it's just so fast because we actually read it from our disk, from our cache here. But the problem here is that it's not only we can fetch that in parallel, We even have this is actually a data waterfall where we have to wait for a previous request. So we first have to fetch Luke Skywalker, then we have to fetch the movies, and then we fetch the characters. So this takes a lot of time. And this actually was a problem of Facebook. So when they built their their mobile applications, they had all those stacked requests that depended on one another. So how would we do that with GraphQL? So there is this GraphQL API, which is hosted by the GraphQL Foundation itself. And this is just a wrapper around this GraphQL, this swappy.dev. And it allows me to look at this REST API from a GraphQL standpoint. And there is already one difference to our REST API. We don't have to call anything to get an idea about the data. We can just head to our Schema Explorer here and drill into our service and have a look at the types. And this is different than if you think about Open API, because this is a real type system. It's not just a snapshot of some types that we exposed in our service that might even be out of sync with our actual server. And I can drill into those metadata and have a look what it actually exposes. For instance, I have here the all people field, and I can drill into that and can see that it returns a people connection here. And then it has a couple of arguments for paging. So I could drill into this people connection, and I can see that it again exposes some more data, like a paging info about where I am in the set, and it also exposes the person themselves. And I can again drill into that and get an idea of this person. And I have metadata here, like what this field actually means, and I can further drill into things here. For instance, I can see that I can directly drill into the films. And then I don't get just an URI as a reference to my film. I actually get the object here. So let's have a look how we can fetch the data. So in GraphQL, we start our queries with a keyword query. And then we can just start typing our GraphQL query. And you can already see that IntelliSense is popping up here because we have all those metadata, so we can get all this help and toolings for our GraphQL API. So I'm drilling in all people here, and maybe I want from the people just the name. And then I'm just hitting the play button here, and I get a list of my people here, of the people names that I want to have. So GraphQL allows me to ask for the data I want. So whereas REST says, okay, I have this request and then has this data structure and I have to consume it. So GraphQL is thought from the consumer. So me, the consumer, can tell the service what I actually want. And to create this algorithm that we wrote, and you saw it was a couple of lines of JavaScript code that I actually had to write on my front end. In GraphQL, I kind of can write that just here by saying, okay, I want the person with the ID. So this is Luke. Let's spell that. You can see this is Luke Skywalker, but I actually don't want to have his name. I know I'm fetching Luke Skywalker. I just wanted the people that appeared with him in that in movies together. So I can drill into the films connection that the character exposes, and grab the films, then drill into the characters that played in that movie, and then get the names. And I'm done. This is one HTTP request that exactly gets the data I want. And it's magnitudes faster. So we are talking about an initial request without warm-up that would be in the 300 milliseconds. and repeated requests that might be even faster. And it depends on how you optimize. If that would be properly optimized and would not fetch actually the data from the REST endpoint, from the REST endpoint that we used before, then it could be even faster. Like you could do one select on your database and just get the data that you need. Okay, let's head back to our slides and reflect. So what is GraphQL, or how does it work? So GraphQL is different than REST. That's what we learned so far. It has only one endpoint because it only needs one endpoint, whereas REST has multiple endpoints for each resource one. And this makes it very simple because I just need this one endpoint, and I issue my request to that endpoint. I can get all the data that I need for a component or for my startup that I need at one specific point in time in one request. And this saves me from doing multiple requests that might even depend on one another. That also means that on the client side, I totally get rid of the over or underfetching problem that we have with REST or other technologies. Overfetching essentially is all the time I have to consume more data than I actually want. And this was the case when I fetched the Luke Skywalker call with the REST. I had to consume all the data that this request exposes. I had to take all the person information about Luke Skywalker. Although I was just interested in the characters that played the movies together with Luke Skywalker. I wasn't interested in Luke Skywalker. I wasn't interested in the movies. And underfetching is all the time I didn't have enough information. And this was also true for the first request. So when I did the first request, I actually over and underfetched at the same time. I overfetched because I got all the character information about Luke Skywalker that I didn't want. And I underfetched because I only got these URIs for the film. And I didn't get the film data. And actually, I didn't even want the film data. I just wanted the list of names of characters. So I had an underfetching and an overfetching problem in all those requests. And GraphQL is built on a strong type system. And that is different from solutions like OpenAPI with REST. With REST, you essentially have this schema document that tells you that the REST API looks like that, but it doesn't have to look like that. And if you return something other than you describe in that document, even if you infer that from C# code, then there's nothing to stop that. And that's different for GraphQL. So if you would return a null value for a field that doesn't allow null, the GraphQL query engine would actually raise an execution error and not deliver that result to the client. So the client really can rely on results in GraphQL, type-wise, and also for things like non-null violations. So if the server says that a field is a string or an int, it will be a string or an int. If the server says that the field is not null, then it will be not null. So you don't have to write all those null checks for certain kind of data because you can rely on the server. And this makes GraphQL really predictable to use, performance-wise and also from a data contract standpoint. On top of that, GraphQL is real-time. For our first demo, we just looked at a simple fetch, so the get in REST. But let's drill in further. Before we go further in GraphQL, let's still get one more thing out of the room. At this point, there's always one person that said, okay, you can do all this dynamic stuff also with REST. Yeah, you can do that. You can create these beautiful requests where you have 1,000 of attributes in there, nobody can read it. and it's a kilometer-long GET request, or even a very complex JSON post document that you have to send. Think about OData, for instance. You have these long UIs where you have compressed your query in. And actually, this UI was not written to write queries in that. So GraphQL has a much cleaner query. Also, if you think about REST, and think about how you worked with your front-end developers. It's kind of like when we develop our backend, we have to always develop that together with our front-end developer. And I mean that in a sense, the front-end developer has a new capability that he or she has to build in. And then they start talking about that with the backend developer and crafting maybe an exact request or an optimized version of that request that has a lot of toggle switches that maybe get rid of some data because they have a new platform, a new device that they have to support that now needs less data for request and something like that. And then the backend person builds that in. And the front-end developer tries that out. And it almost never turns out to work at the first time. Maybe there was misunderstanding. We have these trial and error phases. With GraphQL, that is different. We expose schema. Essentially, we tell you that is our business domain. It looks like that. And then the front-end developer actually can pick and choose what he or she needs from that schema in a certain request. And that's why front-end developer really love that tool. Love GraphQL. It sells itself. You set a front-end developer in front of a GraphQL IDE, and they start thinking about what data they need, and they start crafting these requests, and they will fall in love. I never saw a front-end developer not liking that. So let's dig a bit more in how Facebook thinks about GraphQL, or how they thought GraphQL should be layered and how it should work. In Facebook's opinion, GraphQL is a small layer, very small layer over your business layer. So essentially, GraphQL exposes your business layer in a much richer way. And because GraphQL is a proper type system with unions, interfaces, and all the things we know from proper programming languages, it's very easy to expose your business model, your source of truth to the outside world, to the front-end developers, to the people that want to consume data from your service. When Facebook started publishing their open source specification of GraphQL back in 2016, people started experimenting and saw GraphQL also as a great tool to put over your current infrastructure. Because with GraphQL, you can take this nice layer, this nice type layer, and put it also over your microservice infrastructure or over your old REST service infrastructure, and create this new world for the outside by not having to rewrite everything that you have inside your company. So GraphQL gives the clients, the consumers, the power to ask exactly what they need and nothing more. That's really one of the taglines of GraphQL. It is very important. And that's why people that consume GraphQL really love it. But then there are the backend developers. And when we start talking about GraphQL in the .NET ecosystem, it's mostly backend developers. And they are kind of like, when they started introducing that at Airbnb, they're a bit taken aback. Because the front-end developer can pick and choose what he or she wants, can just craft queries like he or she desires, and that can lead to a magnitude of problems for the backend. because with REST, you can write this request, you can test it, and you know the performance impact on your system. And the fears often with GraphQL, you cannot do that. You can query arbitrarily your system. And that actually is not true. Because in Facebook, GraphQL was actually developed by, or 2 of the 3 creators of GraphQL were actually backend engineers. And it was thought of by backend engineers. So it was designed by backend engineers. And GraphQL actually gives you the power to mold how people can use your endpoint. It gives the backend developer actually much more power over how people fetch data. And since they are no longer overfetching all the stuff that they don't need, they also generate a lot less pressure in certain cases for your backend. And also you can think about things like cost and or query complexity. Things like that can be introduced on top of GraphQL, and they really force people that consume your GraphQL endpoint into not overloading, over-requesting your system. So there are a lot of ways you can constrain how your system is used and really prevent that this overusage of queries that are too big ever happens. And on top of that, you really have those nice type system objects to really describe your API in a much richer way. So let's have a look at Graphql Operations, just to put that in perspective with REST services. So in REST, we talked about it. We have this get to just fetch data, side effect-free reads of data. In GraphQL, we call that a query. And that essentially is what we did in our first demo. Then we have things where you change data. And in GraphQL, you would do, in REST, you would do that with a put, post, patch, or delete. In GraphQL, we call that a mutation because we change data. We have side effects, or we're causing side effects on our system. And then there is real-time events. And this is really powerful in GraphQL. It's called subscription, and we actually don't have anything in REST. There are other technologies, like you could use Signal, you could use WebSockets, but there is nothing baked into the concept of REST to do real-time requests. It's always this extra thing. Before we really head into proper C# code, and there's a lot of C# code I have packed into this talk, let's just do a last thing and have a look at what GraphQL is not. GraphQL is not a database query language. I hope at this point, most of you have grasped this. Since or mainly because of the name, a lot of people, when they hear GraphQL, they think, okay, it's about graph databases. It doesn't have to do anything with graph databases or any other database technology. You could have a file on the GraphQL. You could have APIs on the GraphQL. And I showed that in the initial diagram where you have the GraphQL layer and then multiple service layer on it. So GraphQL actually doesn't care about data sources. It is not bound to any data source. And it's not thought of as a language for databases. There's a query language for databases. And if you look at OData, for instance, it was more born from the database perspective. So when we think very, very back to the first OData, which actually was delivered through this AtomPub protocol, if somebody remembers that, it was very sort from the database, almost like this XML, this is SQL to XML thing that they had in the SQL server back then. I mean, OData has come a long way, but it's still it's still a filter language on top of data sources, where GraphQL is a query language for your application layer. So it's more thought from the perspective of APIs. And this clears one thing up. It's not Facebook's version of OData because it has a completely different mindset behind the development of GraphQL. And GraphQL is also not a good solution for binary streams. While all major internet companies like Netflix, Twitter, and so on are all using GraphQL, nobody uses this to stream movies. So Netflix uses for all of its data requests actually GraphQL, but they're not using that to stream movies. And if you looked at the GraphQL response, it's good for data structures. So it's good for graphs of data. And GraphQL is not limited to HTTP. So while we look at representations of JSON and stuff, it's not bound to that. You could serve GraphQL over gRPC. You could serve it over sockets, and actually a subscription is GraphQL over WebSocket. And what have you? You could use a TCP socket and serve GraphQL over it. And it's also not limited to JavaScript. While it's the most popular in the JavaScript ecosystem, it actually was thought of from backend engineers that used PHP in Facebook, and actually in the front end used native Java and Swift clients. Okay, with that, let's have a look at how that actually works out in .NET. How do I build a GraphQL server in .NET? Let me switch over. Let's get rid of that. And let's start with our first demo. Okay, so this is a very simple, it's actually just a very empty ASP.NET Core server. So I could start it, and it would just .NET run it. Let's just fetch data. Wait, we get that. And you can see it just prints hello here. And if we look at the startup CS, it's not yet the new .NET 6, it's still .NET 5. So we still have the startup CS here. And the only thing it does is it has an endpoint here that maps the GET request and just writes hello to any request that comes in. So very basic. The one thing that is different from the .NET new web template is that it has a package in here, and that is called Hot Chocolate ASP.NET Core. And that is the Hot Chocolate integration in ASP.NET Core server that serves then GraphQL over HTTP. And we are using the newest preview of version 12. So how do we build a GraphQL server? So let's build a very simple GraphQL server where we can actually fetch some books. It's a very simple example that you find everywhere where you can fetch books and authors. So GraphQL, as I said, is a query language for your API. And it's a very thin layer, as we said, over your business domain. So let's create a domain object here, which we call book. That is our entity. So we can just put that in, and we just have a very simple object here. Book has title and author, both strings. And that's our main object for this first example. And then we need something to query that object. And in GraphQL, we have actually 3 root types, we call them, which are object types. And these root types allow us to perform operations on them. So the first we already used, it's a query type. So we can just create something called query. And that is a simple class called query here that has methods or properties on it. And we call them resolvers, because these are actually how we fetch data. So we have here a get book that returns just a new book object. And this new book object has here C# index, and the author is John Skeet. With this, we actually have a working, almost working GraphQL server. Everything that we need is in there. We just need to set that up. Let's do that. So we go to our startup CS, and then we can go to our services here. And we just say, okay, we add a GraphQL server to our services. And then we add the query type. And we take that query class there. But then we have to serve that over HTTP. So we need to go to our endpoints, and we can say just map GraphQL. And with that, we actually have our first GraphQL server ready to run. So we do .NET run. And let me just take another Hatch instance here. And by default, GraphQL is served on the GraphQL endpoint. And if we go there with the browser, we get this nice IDE. And that is the GraphQL IDE our project builds. It's called Banana Cake Pop. All our components have like delicious names. Inspired by Starbucks. Okay. So we can just hit enter here. Then we get a new tab. And then we can actually explore our endpoint. So we can click here on this operation dropdown and can say, give me the schema reference. And then we can see that actually our schema has a query root type. And this root type exposes a field book. And this is where some people get confused, because we actually wrote here a get book. But in GraphQL, you don't have these verbs here because you're doing a query, so it's in get anyway. So you have more natural language where you say books. So this is actually where you drill into a book. So what we do is we are just applying some naming conventions that you can override that make it more GraphQL-like, so that we get rid of the async postfix that we have if it would be an async method, and we get rid of these verbs like get. And then we have a nice GraphQL API. We can drill in here. We can see that we have an author that has a non-nullable string and a title which also has a non-nullable string. Let's get into what non-nullability means in GraphQL in a second. Okay, let's query that. So we go back to our operations tab, and then we, as I said, can write query, drill in. You can see here book. And then we can drill in further. For instance, we just want to have the title of the book. Fetch that and get our request here. So that was easy. We also could maybe just change the request and fetch more. And then we have here also the author. So that was very easy to get initial GraphQL server running. We just created 2 C# classes with nothing specific to GraphQL, and we had a GraphQL server. Very sorry for the background noise. I have 3 kids, and in the evening, it's always a lot of mess in the kitchen.
No worries at all. Don't worry about it.
Yeah, okay. Okay, so this is great. Let's get back to our slides. And here on that, the GraphQL server is not so much work in that. Just putting 2 classes together and we are done. But wait a bit. This was a very stupid GraphQL server. What would we do if we want to put something proper in there, like databases? How would that work with an entity framework scheme? Most prominent question. Just let me say that while I do that in talks most of the times with entity framework, it's only because most .NET developers really want entity framework. But it works what I show with Dapper, it works with Mongo, it works with Neo4j. We are the only GraphQL server in .NET that actually can understand Neo4j. It works with Postgres and anything else. So let's dive in. So this is my first demo. Let's just get rid of it. Is the GraphQL server still running? Let's kill it. Let's lower that down and then go into our next demo. And build something with Entity Framework. So I already have, so I'm using SQLite here. Let's just have a look at the packages. You can see ASP.NET Core here. That's a base package, the GraphQL Server integration for ASP.NET Core. But I also have now a package here specific for Entity Framework, which is called Hot Chocolate Data Entity Framework. It gives some integrations with Entity Framework. There's also, as I said, the Hot Chocolate Data Mongo or some other things. And then I have here the SQLite for Entity Framework Core. All version 5, as I said, we're still on .NET 5 with that. Okay. And to have a proper DB context here, I created some new entities. There's a book entity, and this book entity has now an author entity. So we don't have these two fields, which are strings anymore. We have now proper relations here, where author can have multiple books, and one book can have one author. And then we have here our DB context. Just looks messed up because I didn't build so far. Let's just build that. Reload. And then I should get rid of the squiggles. Okay, so we have a very simple DB context here. And at the moment, our query class is almost like we left it. So we just have here getBook, which just has static data in here. What we will do is now put the DB context in and have a look how that would work with Entity Framework. So first we go to our startup here, and the first thing we need to do is to add our DB context. So let's just add our context here. This essentially just adds the DB context to our dependency injection and puts the connection string in, which uses this local database here. Okay, with that, DB context is set up, and we need to rewrite actually our query, because our query at the moment is static. So let's kick that out and put a new one in. And this one now introduces a method getBooks. This is, as I said, a resolver. And we are injecting into this resolver the DB context as a service. And then we return just the books, and that is a queryable instance. Bear with me, it all will make sense. So let's just start that. So we didn't do a lot, we just injected the service here. And let's run that. No, that was the other one. Let's just get rid of that. Okay, so this is my instance I looked at before. I can just refresh my schema here, and you can already see I have squiggles. It's very fast in our schema reference. And we already can see that the GraphQL server understood that the queryable actually is a list. It's a list of book. And it already inferred from our types that we have an ID, we have an author ID, we have a title, we have an author object, and they are kind of referencing each other. Awesome. So just like that, I can now just rewrite my query a bit. Write books, write title, fetch that. Takes a second to initialize. Let's rerun that, 23 milliseconds. But now we have a list of books that are coming from my DB. It's not anymore static content, it's just querying MyDB. And to prove that, let's just go into our application here, and I'm integrated to Logger that just puts out the SQL that we write. So in this case, we are writing here the select statement to the database and fetching metadata. And we fetch it twice, you can see the SQL twice. But wait, we're fetching just title, but our service actually fetched author ID, title, and ID. So much more. We overfetched actually. And if you would drill in to our author name, then we would get no author. And that's because the Hot Chocolate server actually understands queryable. But that is not the actual integration with the entity framework. We just know what the queryable is and how to build queries on top of that. But we not have any clue that there are projections that we can go into these nested objects and so on. So we can tell our GraphQL server that there are certain things that I might want to do with the data source. So I can go first to my startup again, and then chain in configuration. I can say that there is something called projections. Projections are essentially what you do in a select statement in a link expression. And there is something like filtering, which is when you select certain kind of data, when you write a where clause. And there is maybe something like sorting, which is when you order your data. So we added the fundamental capability to understand the things like projections and filtering to our GraphQL server. So now we can go to our specific resolver and add now middlewares for maybe paging, for projections, for filtering, and for sorting. And before I show you what it does, let's just go to the slides. And let me explain something here. So I'm putting attributes here on my query class. And just one thing. This is the attribute way to do it. We also have a Fluent API if you don't like attributes. But what these attributes are middlewares, field middlewares. And they allow me to create a data pipeline on top of my resolver. So meaning that this actually, when it compiles, when the server compiles, we are building this middleware pipeline where the request for this field will flow through the first pipeline, and there is the next, and it's essentially like an ASP.NET Core pipeline. And we will, in the data pipeline, just refer to the next pipeline until we hit the resolver. The resolver will return the queryable, and then the sorting middleware will apply a sorting expression onto that middleware, or onto that queryable, and pass that queryable on to the next middleware, where the filtering middleware will apply where clauses to the queryable. And then the selection middleware, the projection middleware, will actually apply projections to it. And then at the end, we will cut the data to only get the data that we requested. These middlewares have an order. So order with middlewares, whether it's in ASP.NET Core or in Hot Chocolate, matter. Meaning if you would put the use paging middleware at the very beginning, essentially the resolver is always the last middleware in the pipeline. If you would put it right after the resolver, we would first cut the data and then apply sorting, which is kind of sensitive because you get the first 5 items, then you sort it, and then you filter on the first 5 items. So middleware order matters. So the order here is the middleware order. So essentially, the pipeline that I depicted is this. Essentially like I did in the diagram. So the order of these attributes matters. You can have custom middlewares in between those, but the general order matters. And the Graphql Server would actually throw a schema exception when you build that, if the order is wrong with version 12. Okay, so let's run that again. Go to our Graphql Ide. Let's refresh, and we can see that there is something that has something changed. So let's go to our schema reference, and then we can see that we have a book connection. And I don't know if you remember from my first example, we had all those connection types, and connections are essentially our paging types for cursor-based pagination. That's where we have information about our paging. So essentially, the books field now returns this connection, which gives us information about where we are in the page. Is there a next page? The cursor, how we get to the next page, and so on. We go back to the query, and then we have other information like the nodes, which exposes the books, and that's the actual object we want to use. So let's go to our operation and just rewrite that a bit. So we can now do nodes on this, and then actually our thing should work again. We should be able to execute it. We get the data, so everything is fine. But we actually applied all those middlewares. What do they do? So let's again go to the schema reference. Let's go to the query here. And then you can see these are the arguments that you can pass into that field. And we can see that there is a where argument on it and an order argument. So I'm now able to just drill into my data here, or filter on my data. For instance, let's get all the books of Jeffrey Richter here. So we kind of say we want we only want books of the author with a name that contains Richter. Very simple request. And maybe we just want the book titles because we know it's Jeffrey Richter that we get there, and then we execute that. And then we get only the titles that belong to the author, Jeffrey Richter. But what actually happened here? Let's have a look at the SQL. Because now we understand what the query will actually is capable of. We know there's entity framework behind it, and we can rewrite it. So we only select the title that we need to get the data from. And we also can join that with the author and do a proper filter here on top of our query that we introduced there. So we just rewrote the GraphQL into one SQL and fetched it from our database. Yeah. Okay, that is fine. So if we then would drill into our author, get the name maybe, we also can see that we now select the name and the title. That's awesome. Okay, let's do something more, because GraphQL is great. It's the gateway I said. So we could aggregate data from a different data source into my SQL, into my database data. So maybe I have another REST service that provides me like with book descriptions, like this one here. This is a JSON array with some data. Maybe this is the ID of my book, and it provides a description. Let's say this is a service, another REST service. So how could I integrate it? So there are various ways to do that. But a very efficient way is to use a data loader to access the data and merge that into our GraphQL queries. So let's have a look at that. So the first thing I will do is add a new data loader that will do the data fetching from my service, my book details service. So we have a book description ID data loader. Let me just put the namespace in here. Namespace is maybe a demo. And and then I prepared some code here. Let's just import it and I'll walk you through. So this is a batch data loader. What the batch data loader does is it allows your resolver, and we will see that in a minute, to ask for data, but the data loader will actually not immediately execute it. It will wait for all the fields in the GraphQL execution engine that need a certain kind of data to register their call. And when all fields register their call to a certain kind of data, in this instance our book detail data, it will batch them in one go. So essentially, we will only once read this books.json, get all the data we need, like for all the IDs, for all the keys that were requested by any field in our service that needs book details. And then we will create a little map that only has this data and return it to the execution engine. Okay, so we created our data loader, which is kind of a simple thing. It's you just have to implement this load function, which gets the keys, and then you write some logic to get it from a database or from a different service. So the next thing is we want to add to this books entity in GraphQL actually a field description. So we create a new type that we call book details.cs. And let's just give it a namespace here, demo, and then put in the book details type. And this actually is an extension type. So we are extending, so this type extends the book type, the original entity. We don't have to change the entity. That is your business code. We don't change that. We just tell our GraphQL server that this type and the book type actually has to be merged. So the next thing is that we create description resolver. Again, this is a resolver that will fetch. It will fetch for us data. So this books resolver actually needs a book. And for this book, we want to resolve the details, the description. Okay, and this would work, but we are writing the SQL dynamically, right? So we need to tell the execution engine about our reliance on the actual ID that we need here. So what we do is actually say now that we need a field ID. And this field is from book. Is from book. And it needs to be projected always when we call this resolver. Okay, that should work. Then we just, let's put that together. We just go to our GraphQL configuration, add type extension, book details, and then let's see what our service will do with that. We're almost through, by the way. We have one more demo left, and then we are done. Okay, we're going back here, and just doing a refresh. And now we should have a new field here, description. And this actually gives me these detailed information to our books. Let's run that. And we can see here we have the description. Actually, it's again 26 milliseconds for the database call. And we get here the data that we wanted. If we look at the console, we can see that we get this request here, and you can see that we are selecting title, we are selecting name, and because we are getting the descriptions, we are selecting ID from the database because we need that to fill into our data loader. And the data loader, you can see, is printing out for which data it's reading here descriptions. So this data is merged, and from an API standpoint, the user, the consumer again, doesn't feel a thing. The user doesn't know that there are multiple services behind this and that the data is merged and batched and stuff like that. No, the user just sees, okay, I have a description field here on my type. In my schema reference, if I look at books, I have a description here. And I have the book as it was intended by my domain model. Okay. That's how you can interact with databases and other data sources. But there's one more aspect. And while we haven't looked at mutations, we're going to go all the way to real time, so subscriptions. And we also will, at this point, look at some mutations, because we will have a service that adds new books and then has a subscription where you can subscribe to new book releases. So let's make it real time. Let's go back. This is the last demo we do for tonight. And then we'll have a look if there are questions. So CI, demo 3. Okay, so this is actually the same server again, a bit further developed, and I'll just walk you through. Let's just reload that. Okay, so we can already see we have a query here, and the query type now allows to query for books. It allows to query for authors. It allows you to get a specific author by ID and stuff like that. So you really can drill into more data here and do a lot more things. It also has a mutation here where we can add a new author, we can add new books, and let's have a look at how that feels. Let's run that. What's wrong? Get that here. Oh, I killed it. Let's go just on the endpoint again. Enter the parameter key. That was unexpected. Either the parameter query or parameter ID has to be set. Okay. There's always a demo failure. Let's have a look at what is wrong here. Okay. Somehow the schema is missing something. I think I know. And then we have these guys. Yeah, book details. Query type is there. This is there. We have the DB context there. Course is enabled. The Graphql Server seems to not like what we did. Okay, strange. One second. There is, I know. Just. That is very strange. Okay, let me just drill this in. So this is a preview version that I'm using. And it kind of is messed up. This is Safari at worst. So we are still, so there are a lot of more features coming to version 12. And it seems like my browser cache is messed up. On here, it just works. Okay, let's just keep that. And I'm using Safari now. And we can go on here. Okay. So server is not broken, just my GraphQL Ide. Okay, so I explained already we have query, we have mutations, so there is a lot of things we can do now. And just to give a brief, I'm just flying over that because the mutation, there's often a question: how do I write mutations in GraphQL? You always write them like you're writing queries. The one very important thing is GraphQL only has top-level mutations. So there is no thing like a nested mutation. Like if we go to our thing here and say, okay, we want to do a mutation, then we can go here and say, maybe add author. And only this is a mutation. So everything that comes below here is a query. And this is really baked into the execution engine because the execution engine knows this is a mutation. This changes data. This is not allowed to change data. And this has a really important effect because this produces the change. And then down here, you can select the changed state. Meaning, like if I add a new author, let's do that. We add a new author. This author is called Michael. And I can just get the data, maybe the ID of this Michael, and all the other affected objects of this change. So I essentially allow the client to do a change and to reselect all the changed state, or the state that I have changed from the server. And by this, avoiding multiple calls for then consecutive query calls. And since I can do multiple, like I could do maybe add my author A here, and then add another author B here, the execution engine really allows me to do that. That would be one batch to the database, and it would execute first this resolver, then this resolver. Everything down here is executed in parallel, meaning there is no order, there is just pure chaos, because that is side effect-free reads. We should be able to do them very efficiently, very fast. Okay, but we want to talk about subscriptions. So let's head into that. So how can I introduce subscriptions to it? So we have the first ingredient here. We have this mutation. So every time I write a book, I'm causing something to my system. And what I want to expose is essentially a subscription that, that you can listen to for new book releases. So it has to do with this mutation. So let's start. So the first thing to be able to do subscriptions is we again go to our GraphQL configuration, and we then change just in another thing, and that is called an in-memory subscription, an in-memory subscription provider. Like in a real system, we would have a Redis subscription provider that maybe has a Redis pub-sub behind it to better scale and be able to subscribe to any node that you have. Maybe you have Kubernetes, you have a couple of GraphQL server nodes, then you're allowed to subscribe to any of them. And we really organize it through Redis. There could be other systems, by the way. It's not bound to Redis. Now for our experiment here, we just use the in-memory provider. That means you can only work with one instance. And everything is in memory. Okay, the next thing is, so we create root types for query, for mutation. So we need another root type for subscription. Call it subscription. Like any other root type. Subscription. Okay. Just add the namespace, demo. And then we add our subscription type. Oh, sorry. Okay. So the thing with subscription, it only works like almost works like a query. So we need a resolver. So our resolver should be called onBookReleased. And let me just import that book data here. So what it does is this onBookReleased will return a book. So I can subscribe from GraphQL to it, and it will return a book. And in this case, it will also receive a book. So I'm saying I want an event message. I'm subscribing to an event message here, which is called book. It could also be just the ID of the book, and then we would do in this resolver some data fetching. But in this instance, we just say we are subscribing to the book message. The next thing is that we need to put an attribute on this. It's called subscribe, so that makes it clear to the schema builder that this really is a subscribed resolver. Also, we need a topic, because there could be a lot of book messages, but we want to listen only to a certain topic. So we put a topic attribute on it, and this will make this resolver the topic. You could also have a dynamic topic or specify the topic explicitly by putting a name in here. We just go with default, just let this resolver be the topic. Okay, and then we just add that again to our GraphQL configuration. So we add that here to add subscription type. And we add our subscription type here. And then this is actually in. Our subscription is set up, but it's never been triggered. So we now need to go to our mutation that actually adds books. And this is this add book async. And then we kind of want to send a message, a book message, to our bus whenever this book is changed. So what we do is we need to kind of inject the event sender here. So we have an internal abstraction for these subsystems. So we can say we need a topic event sender, and it's a service. And whenever we are done with adding the book, we can just send this. And I set the topic is the name of the subscription resolver, so we can just say this is the name of, this is our topic, and then we're sending along the book. This might not be a good idea to, depending on how large your entity is, and if you're using Redis, is it a good idea to send all this data onto your pub subsystem? I don't know. But you also, as I said, could have proper messages that you abstracted that only has the data that the resolver then needs to get all the data then from the database. Okay, but this is it. This is all we need to create a real-time GraphQL server. Let's run that. Okay, we are running, and this time I'm using the Banana Cake Pop IDE application that we also have. Let me just grab my Safari here. Where is it? Okay, this is our IDE that we have running on the server. And then I have here an application. Let me just quickly connect to it so that we have two instances. So we can prove that real-time really works between multiple client instances and stuff. Just get a book. I can drill in here. Let's fire that up. Yeah, you can see in my server, the data is coming from my server. So this is now also connected to our backend. And what I want to do is now not a query. I actually want to have subscription data. So a subscription is written almost like a query. I'm just writing subscription here, and then I can write it like any other query. I drill into the subscription I want. In this instance, on book created, and then I'll pick the data I want. For instance, title, and then I fire this query. Okay. And there is an error. Because this doesn't exist. Let's refresh that. Yeah. On book released. Okay, I didn't refresh my schema properly somehow. Let's just redo that. On book released. I fire that up again. Okay, and now it waits. You see the donut here. It's going around. It's actually waiting for real-time events. Let's put that down here. And now I'm grabbing my other Graphql Ide. Let me get rid of that. Yeah, get rid of that. And I'm writing a mutation. But before I do the mutation, let me just grab an author ID. Authors. I just need one ID. One. I could have guessed that. Okay. So now we write a mutation and we are publishing a new book for author 1. So we have this input. This is the book that we want to publish. It is maybe, I don't know, my first book. And it's written by author 1. And I just want to reselect the book ID. Actually, let me stop that. Let's just put the ID in as well. We run that. We are subscribed. And now let's run this request. And you can see here I created book 12 and I get the data book 12. So real time is very simple. Also, again, from a consumer perspective. I mean, from a backend perspective, you still have to think about having a pub subsystem also in the backend, like Redis, that scales your subscription. And also you have to think about scaling socket connections, because now we're using WebSockets. That means how do you scale them? There are solutions for that as well. Like you could offload all the work to Microsoft and use Azure Web Sub. Or you do a little bit more work yourself. But from a user perspective, that is really simple to do. You just subscribe, you write the query like any other GraphQL query, and you get the data that you want. And this is really powerful to then use this data. Okay, with that, my last demo is done. I hope you enjoyed and learned something new from that. Maybe have an inspiration to put some GraphQL over your old infrastructure, tip your toes in GraphQL. It really is fun to use and can really supercharge your systems everywhere. What should you take away from that talk? So with GraphQL, you can iterate faster because you essentially create this one model, your business model, that people then can use. You don't have to create specific requests for specific devices or specific use cases. You just create this this one API to rule them all, and then people can pick of this API what they need. You still have control over the types, and I would say you have more control than with the REST API. And there are a lot of tools around GraphQL to really make them tight and prevent people from just arbitrarily querying your system. And that is also one important aspect you should have gathered from the demos. Let me just show that one more time. Because the query endpoints, you are fully in control of what you expose here. So you cannot just query things that you didn't expect it, because we provided the root endpoints that you can query. And you also can control the filters that we exposed through our filter system and stuff like that. So you're fully in control as a backend developer. And with cost complexity analysis and stuff like that, you really have more control than with REST, and can control that there is a consistent performance of your server. From a user standpoint, it really is so much simpler to use GraphQL than anything else. So for the consumer of your API, for the backend, okay, you have that extra work to think about your schema more closely than just creating another REST request. And with that comes much more efficient data fetching. As I said, for the consumer, you're creating a really nice environment to interact with your business domain. If you want to have some literature, there is a good book, Production Ready GraphQL. I also read it, I also own it. It's written by Marc-André. He's working at GitHub. And GitHub was one of the first implementers that used GraphQL when it came out. So it was one of the first platforms to pick it up. Today, as I said, all the big internet companies are using GraphQL. And not only internet companies, the New York Times is using GraphQL in the backend. Then you have Facebook, Twitter, and Microsoft is starting to look into it, and others. So there is a lot of companies that are actively using GraphQL. Microsoft is not only looking into it, Teams, for instance, is running on top of GraphQL. So if you have Teams, the old Teams version is using Angular and GraphQL, the new Teams version is using React and GraphQL. If you wanna start with hot chocolate, you can go to our website, chillicream.com. You can follow me on Twitter if you want. And we have a great community on Slack, so you can join our Slack channel. It's slack.chillicream.com. And we have a very, very active community. And we also put a lot of work into our community, help them start with GraphQL. So join us and join the fun. And with that, other questions?
Hi, yes, there are. But first of all, thank you for all of that knowledge that you've shared with us, and those awesome demos as well, like so well prepared and really thorough demos. So thank you. That's always like what brings it to life, isn't it? It's all theory until then, and then seeing it in .NET as well, it did really bring it to life. And like you said, a lot of when I first heard of GraphQL, it was maybe more of my JavaScript developer friends that were like, yeah, GraphQL, you've got to get in on this. And you know, I'm a .NET dev, so I was like, yeah, okay. And then as I've seen it more and more be adopted by .NET developers as well, so I do think it is, like you're saying, there's so many big companies using it now, it's becoming the way to be able to query your data. And it's really cool. Thank you for sharing that. We've had some really good feedback. I guess first of all, we can show a comment from Craig saying it was a really good session, and the last demo in particular was really good.
You're welcome.
And we've got some questions. So Zafar asked, so I know you showed us the entity framework version, but asked, is it possible to generate GraphQL types from Postgres tables automatically using Hot Chocolate?
Yeah, and so we are looking into that. With version 12, this is possible for Neo4j, and we are making this possible also for Entity Framework, and you can do that then with Postgres. but we are also looking further down the line. So version 12 will come out somewhere in August, so very soon this month. We're still ironing out bugs. So Neo4j and Entity Framework will be your option there to automatically generate stuff. There are already demos for this for Neo4j. But further down the line, we will make that easier and also support SQL Cutter. We also have a prototype for that. So if you're doing Postgres with SQL Cutter, this is also then supported to generate. Yes.
Awesome. Great. We've got a question from Kev about what's the difference between a data loader and data stitching, and schema stitching, sorry, and which would use in what scenarios?
Depends. So a data loader is a tool to make your data fetching more efficient. Like if you have, so if I have data from multiple data tables or things like that, I really would or downstream services or somewhere else, and I want to stitch them, is the wrong word, but get them in my schema, then data loader can be a very good tool, but it's the same service. So you will end up with one big service, one monolith. That is also one good thing about GraphQL. It's a monolith for the outside users. But this can be a challenge if you're working in a large team. And as I said, I'm working as a contractor for Swiss Life. It's a big insurance company. And they're at the moment creating the one graph for their company with multiple departments working on that. So one graph in that instance is kind of a hindrance for the developer process there. In that instance, schema stitching can be the solution. Because now you can chop up the service in multiple service instances. So you would end up with multiple GraphQL servers in that company, where each department or each team owns a certain aspect of the graph. And then there is a GraphQL gateway that takes all those GraphQL endpoints and merges them into one graph for the company. So in that instance, where you have multiple teams working on your server, it can be beneficial to use schema stitching. But I, in general, tell people start with one graph, start with the monolith, because it's very easy, and you anyway have to learn GraphQL at the beginning. Start with the monolith and then chop it up. It's always easy to chop that up, multiple GraphQL servers, and then use schema stitching on top of that.
Yeah, start off just getting it working and refactor it down if you need to.
Yeah.
And another question from Kev is, and can mutations be done on multiple schemas, such as from different GraphQL APIs merged together?
That is a capability. So I think that goes for schema stitching. And yes, that is something we will bring with the September release. For schema stitching. So with the September release, that is version 13, which might be October because we are already late with version 12. So let's say it's the October release. We are bringing a new schema stitching layer that will allow you to merge multiple mutations and a lot of other nice things like code first schema stitching.
Nice. Just while we wait on any more questions coming in, I can say that I think we've got our furthest travelled virtually a comment from Washington DC from Ari. I don't know what time it is there, but you're our furthest travelled, so thank you for joining us. And we've got a comment from Ewan saying thank you, it was super interesting and glad it's on YouTube so we can rewatch. And I agree, because there's so many cool demos there that there's so much to like, I want to pause it and do some work and then be able to follow along.
Yeah, we also, I can show that it's maybe a good thing. If you get started and want a more complex example, we actually have on GitHub the Grafter Workshop. And that is a good walkthrough. Let me just fit it out here. The workshop, and so it's on Chili Cream Graphql Workshop. And it's a step-by-step example, starting with a simple GraphQL server, then talking about aspects like nullability, how that works in GraphQL. And it goes really until you build complex real-time functionality. And this is a bigger example. We took the schema from an example that C# Fritz actually built from the Microsoft team. And we took that and made it a GraphQL server, which is really a bigger example that you can then run. And also you can do here online queries on top of it. So there is a lot around that.
That's cool. Thanks for that example repo, because that's the best way to learn for me. Is have real examples, and as you say, get more and more complex as the examples go on. That's awesome. I really like, is it Banana Cake Pop? The kind of UI that you can query your data. That's so cool.
Yeah, we actually. So when we started with the project, we were looking for a name, and then we came up with hot chocolate because my son always wants a hot chocolate when he said Starbucks. So we just said, let's take something that people will remember, something silly. And from that on, we have a lot of silly names. Like the client is called Strawberry Shake. And
well, you know what, it's memorable. And who doesn't like hot chocolate? So
yeah.
And other Ewan it said, thank you so much. Thank you for it. Is it feature creep for pet projects? I think. Yeah, I agree. I think I'm going to lose the weekend to this now, because I think I'm going to be having a play around with all these cool things that you've shown us. But yeah, I'll leave it a few more seconds if anyone's got any more questions or comments. But just again, another chance, Michael, to say thank you for spending your evening with us virtually in Scotland, and for your awesome talk. That was great.
Thanks for having me.
Great. So for our next meetup, we will confirm the date soon, very soon. I think it's going to be end of October, and we're going to have a talk about Next.js. So we got some feedback. We'd like to have more talks on JavaScript. So we're going to have Next.js, and I think the meetup after that might be around back to .NET, .NET-Conf, because that's in November. So the year's flying away already. And then again, later in the year, some talks on AWS. So we're trying to diversify the tech stack, and look at some different technologies as well. So we've got lots to look forward to in the next few months. But if anyone wants to volunteer to give a talk or wants to suggest anything we should get speakers on to talk about, like, just ping us a tweet, send us a message, and we'll look into it and get back to you. But for now, we'll say goodbye, and thank you everyone for spending some time with us.
Goodbye.
See ya.